Hi everyone, so welcome to the channel. So in this video we are going to discuss the remaining problems of exercise 8.4 of similar triangles chapters of class 10. So for the previous videos, so please visit my channel so that you can find out the remaining problems of this exercise 8.4, right? So if you are new to this channel, so please subscribe the channel and share with your friends. So watch the video till the end so that you will be getting all the problems and share with your friends so that it is useful to them also. Okay, let us see question number 7. So what is given? O is any point in the interior of the triangle ABC, and he has given that OD is perpendicular to BC. So this is nothing but my point O. So OD is perpendicular to BC and OE is perpendicular to AC and OF is perpendicular to AB. Then we need to show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. So this is the first thing that we need to prove, and the same way we need to prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So these two things we need to prove here, right? So for that, first of all, so if this is perpendicular, then this side is also it is perpendicular. So here also it is perpendicular and here also it is perpendicular, right? So if you observe these figures clearly, so if you want to apply Pythagoras theorem, since we have right angle but we don't have triangles, so for that what I am going to do is I am going to join O with B, O with A and vertex C with this O. Then automatically I am going to have 6 triangles. So all these 6 triangles are right angle triangles. If you observe carefully, all these 6 triangles are right angle triangles, and at the same time OA, OB and OC acts as hypotenuse. Since we have 6 right angle triangles, so considering these right angle triangles and applying Pythagoras theorem to each right angle triangle, then we are going to have some relations. Okay, so what I am going to do is I am going to consider each triangle in clockwise direction, and after that what I am going to do, I am going to do the operations or the things that we require here, right? So first of all, I am going to consider triangle AOE. So I am starting with this triangle. Likewise I will move on in clockwise direction. So in triangle AOE, so if I apply Pythagoras theorem, so by Pythagoras theorem what I can say, so this is nothing but OA is nothing but my hypotenuse. So from this what I can say, OA square is equal to OE square plus AE square, OE square plus AE square. So let this be equation number 1. The same way, next moving on to the next triangle, triangle COE. I am moving in clockwise direction. So by Pythagoras theorem what I can say, OC square is equal to OE square plus CE square. I can write as OE square plus CE square. So this is nothing but equation number 2. The same way, moving on to the next triangle, so this triangle also completed. Next moving on to ODC, triangle ODC. So by Pythagoras theorem what I can say, again OC square is equal to OD square plus CD square. So let this be equation number 3. The same way, moving on to the next triangle, what is the next triangle? ODB. So this is my next triangle ODB. Again by Pythagoras theorem what I can say, OB square is equal to OD square plus BD square, right? So let this be equation number 4. Next moving on to the next triangle, triangle OFB. So when I consider triangle OFB, again by Pythagoras theorem what I can say, OB square is equal to OF square plus FB square. So let this be equation number 5. Next, moving on to the sixth triangle. So in sixth triangle, what is sixth triangle? OFA. So it is nothing but OFA. By Pythagoras theorem, what I can say? OA square is equal to OF square plus AF square. So let this be equation number 6. So totally how many equations we got? So we got 6 equations, right? We got 6 equations. Now we need to arrange them properly, so that I am going to have OA square plus OB square plus OC square minus OD square minus OF square minus, so minus OF square is equal to AF square plus BD square plus CE square. Now let us see where we are having AF square. So AF square is present here in 6th equation. Next, BD square is present in 4th equation, and CE square is present in 2nd equation. Then what I can do is simply I am going to add equation number 2 and equation number 4 and equation number 6. So what we are doing here, we are adding equation number 2, equation number 4 and equation number 6. So when you add, what will happen? Left hand sides will be added to left hand sides, and the right hand terms will be added on the right hand side. Right? Now 2 plus 4 plus 6. So what are the left hand sides of 2 plus 4 plus 6? It is nothing but OC square plus OB square plus OA square is equal to, what are their corresponding right hand side? OC square corresponding side is OE square plus CE square plus, next corresponding right hand side of equation 4 is OD square plus BD square. The same way right hand side of 6th equation is OF square plus AF square. Now from this OE square, OD square, OF square, if I transpose to left hand side and rearranging and writing, so what will happen? So this I can write it as OA square plus OB square plus OC square. This I have rearranged and written. Next, these three terms OE square, OF square, OD square, if I transpose to the left hand side, their signs will change. Then it becomes OD square minus OE square minus OF square is equal to, what are the things that are left over? AF square plus BD square plus CE square. So this is nothing but my result, first result which he asked. So to obtain that, what we have done, we have added 3 alternate equations. When you consider it in clockwise order, then 3 alternate equations we have considered and we have added, and after rearranging we got the first one, first relation, right? The same way, now moving on to the second relation. So what is the second relation? AF square plus BD square plus CE square. AF square plus BD square plus CE square is equal to, we need to show that AE square plus CD square plus BF square. So for that, what I am going to do is, this time I am going to consider equation 1 plus equation 3 plus equation 5. I am adding equation 1, equation 3, equation 5. So all the things are alternate, right? Now when I add these 3, what I am going to get on left hand side? I am going to get OA square plus OC square plus OB square. So these are nothing but the left hand side terms, which is equal to, first equation OE square plus AE square plus OD square plus CD square plus 5th equation OF square plus FB square. Right? Are you clear with this? So let this equation be nothing but my 7th equation. So what the result I got? Okay, so let this be 7th equation. Now observe, here I am having OE square, OD square, OF square. So if I transpose all these terms to the left hand side, what will happen? And rearranging and writing, so OA square plus OB square plus OC square, this becomes minus OD square minus OE square minus OF square. This gives me AE square plus CD square plus FB square. right? So let this be equation number 8. Now if you observe the left hand sides of equation 7 and equation 8, observe the left hand sides. So both left hand sides are same now. So if both left hand sides are equal, then automatically right hand sides are also equal. So from that, what I can say, from 7 and 8, from equation 7 and 8, what I can say, AF square plus BD square plus CE square is equal to AE square plus CD square plus FB square, right? So likewise we can prove this particular question. Okay, so what we have done, so we have considered the 6 right angle triangles, and in clockwise order we have taken the triangles and applied Pythagoras theorem, and after that we have taken the triangles alternatively and we have added them. So based on that we got these two results. Okay, next moving on to one more question. So question number 8. A wire attached to a vertical pole of height 18 meters is 24 meters long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? Right? Now let us see what the question means. A wire is attached to a vertical pole of height 18 meters. So there is a vertical pole. So this is a vertical pole, so which is having 18 meters height, and there is a wire, so which is 24 meters long, so that it is having a stake at the other end. So stake means, so to fix it onto the ground, so there will be some type of arrangement. So with that we need to attach this wire on the ground, and he is asking how far. So how far means, so what should be this distance so that the wire is, so that the stake should be driven. Stake means this end, so this end should be driven so that the wire will be taut. Taut means, so without any folds or wrinkles. So we need to fix that wire. Okay, now clearly what you can understand, so this is a right angle triangle because this is my ground and this pole is always vertical. So vertical means it makes 90 degrees angle. So clearly I need to find out this side, and I am given with the hypotenuse as well as one of the sides. So clearly what I can say, so by Pythagoras theorem, what I can do, hypotenuse square, so which is nothing but 24 square is equal to 18 square plus I need to find this distance now, so let it be some d square. Now what is the value of 24 square? So 24 square is 576 is equal to 18 square is 324 plus d square. Since I need value of d, so d square is equal to 576 minus 324. Now on doing subtraction, 6 minus 4, 2. 7 minus 2 is 5. 5 minus 3 is 2. Right? So d square is equal to how much? 252. So from this d is equal to square root of 252. So what is the square root of 252? So what is the square root of 252? So it is nearly about 16. So that means I can simply consider it as some 13.9 meters. So it is nearly 13.9 meters. Okay, so likewise you can consider the values. Otherwise, so 252, so if you do the LCM, so prime factorization, so how can I write this as? So with the 2 table, so 1 time, 2 times, 6 times. Next again, so 2 table, 2 6 are 12. Next 2 3 are 6. Next 7 9 are 63. Next 3 table, 3 times. Then how can I write this as? Square root of 2 into 2 into 7 into 3 into 3. So instead of writing this, so how can I write this as? So how can I write this as? So square root of 2 square into 7 into 3 square. So this 2 square and 3 square, when they come out of square root, they become 2 3s are 6. So 6 into root 7 meters. So instead of considering it as approximate value, you can write the exact value. So 6 into root 7 meters. Okay. Next, moving on to question number 9. So two poles of heights 6 meters and 11 meters stand on a plain ground. So two poles means, so they will always be perpendicular to the ground. So one is 6 meters. So 6 meters means it will be short, and one is 11 meters. So it will be the tallest one. Now this is my 11 meters. So let the 6 meters pole be named as AB and the 11 meters pole be named as CD. Next, what he has given, if the distance between the feet of the poles is 12 meters, so that means the distance between these two is 12 meters and this pole is 11 meters. Now find the distance between their tops. Find the distance between their tops. That means he is asking you to find this distance. So this BD distance. So for that, what I am going to do is, so already we know these are perpendicular to the ground. Next, what I am going to do is, I am going to draw an imaginary line which is parallel to this. Then what I can say, since this is perpendicular, so this will also be perpendicular. Next, since this distance is 6 meters, this is also 6 meters. But this total height is 11 meters. Since this is 6, then I can say that this is 5 meters. And since AC is equal to 12 meters, and let us consider this point as E, then BE also 12 meters, because these all are perpendiculars. That means it is forming a rectangle. In rectangle, opposite sides are equal. So this is 12 meters. Now I got a triangle, right angle triangle BED. So in triangle BED, I can apply Pythagoras theorem, no? So by Pythagoras theorem, what I can say, BD square is equal to BE square plus DE square. Now directly substituting the values. So from this, what I am going to get, BD square is equal to, what is BE? So BE is 12. So 12 square plus DE is 5 square. So 12 square is 144 plus 5 square is 25. So 144 plus 25 is 169. So which gives me BD square value. So from this, BD is equal to square root of 169. So square root of 169 is 13 meters. So from this, what I can say, distance between their tops is 13 meters. So the answer is 13 meters. Next, moving on to one more question. So in an equilateral triangle ABC, D is a point on side BC such that BD is equal to 1/3 of BC. Prove that 9 times of AD square is equal to 7 times of AB square. Now let us see this problem. So what he has given, ABC is an equilateral triangle. So equilateral triangle means what we can say, all the sides are equal. So let this be triangle ABC. That means what I can say, ABC is an equilateral triangle. So ABC is an equilateral triangle. So clearly what I can say, AB is equal to BC is equal to CA, which is equal to some A I am going to consider. Right. Next, D is a point on side BC such that BD is equal to 1/3 of BC. That means if you divide this particular side into 3 parts, this point D is nothing but 1/3 of BC. So already we know BC is equal to A. So from this, what I can say, so BD is equal to 1/3 of BC. So instead of BC, I can write it as A by 3. Now this length is A by 3. This length is also A by 3 and this length is also A by 3. Okay, next. So this is AD. So AD is 1 by 3. Next, what I am going to do is, let us consider this point as E. Then if I join, so this also will make the side into 3 parts. So Next, what is he asking? D is a point on side BC. Prove that 9 times of AD square is equal to 7 times of AB square. So for that, what I am going to do is, I am going to drop a perpendicular here. So I am going to drop a perpendicular AF. So what do you know about perpendicular? So this is nothing but my altitude. So what altitude does? So in an equilateral triangle, the altitude divides the base into two equal parts, right? Since so this total length is A, that means this part will become A by 2 and this part also becomes A by 2, right? So the altitude will divide the base into two equal parts. Since the total length is A, so this becomes A by 2, and so BF is A by 2 and FC is also A by 2. Now next, this DF value. So this DF value, so since this part is A by 3, right? So BD part is A by 3 and DE part is also A by 3. Now till here, till F, BF is nothing but A by 2 and BD is equal to A by 3. Now if I want DF, so what I am saying, BF is equal to A by 2 and already BD is equal to A by 3. Now if I need DF, so from the figure DF I can write it as BF minus BD. I can write DF as BF minus BD. So what is BF here? So BF is A by 2 minus BD is A by 3. Now on taking LCM, so LCM is 6. So this gives me 3A minus 2A. So which is equal to A by 6. The value of DF is A by 6. So this part is A by 6. So from here to here, this part is A by 6. Okay. Next, already you know altitude of equilateral triangle. So altitude of equilateral triangle is nothing but, so already we have proved in question number 2. So altitude AF is given by root 3 times of side by 2. So altitude is given by AF is equal to root 3 A by 2. Okay, already in question number 2 we have proved it. So if you haven't gone through that video, so please go through that video, right? So AF is equal to root 3 A by 2. Now if you observe this, in triangle AFD, so clearly triangle AFD is nothing but a right angle triangle. So now you might have understood why we are considering the altitude here. So in triangle AFB, simply by applying Pythagoras theorem. So by Pythagoras theorem, what I can say, AD square, that is nothing but hypotenuse, is equal to DF square plus AF square. Now when I substitute the values, already I know AD value, so I don't know AD value, so let it be AD only. So AD square is equal to, what is DF here? DF is A by 6, so A by 6 whole square plus AF. So where is AF? So AF already we have written here, it is nothing but root 3 A by 2 whole square. Now when I am doing this, so what I am going to get, AD square is equal to, this becomes A square by 36 plus root 3 A by 2 whole square means 3A square by 4. 3A square by 4. Now from this, AD square is equal to, what is the LCM? 36 and 24, it is 36. 36 in 36 it goes one time, so this is A square plus, in 4 table 36 9 times, so 9 into 3 square, 9 into 3, so it gives me 27 A square. Now on cross multiplying, so this becomes 36 AD square is equal to A square plus 27 A square is nothing but 28 A square. Now already you know A square, so A I can write as either AB or BC or CA. So I can replace this A square with AB. Since I need AB, so I can write it as 36. So here this 36 and 28 can be cancelled in 4 tables, so this goes 9 times, this goes 7 times. So clearly I can write it as 9 times of AD square is equal to 7 times of AB square. So this is nothing but the proof of this particular question. So either you can write as 7AB square or 7BC square or 7CA square. So any of the values is valid here in this particular question. Right, next moving on to one more question. So before going that, so this is one of the important questions, so which was asked in NTSC also. Right, next moving on to the next question. So in the given figure, ABC is a triangle right angled at B. DE are points on BC. Trisect it. So trisect it means it will be dividing the given BC into 3 equal parts. Then prove that 8 times of AE square is equal to 3 times of AC square plus 5 times of AD square. Now follow the things. So AC square means this hypotenuse, right? AC square means this hypotenuse and AD square means this hypotenuse. So we all need to play with those hypotenuses, right? From this what have you understood? So since we have 3 right angle triangles, first one is ABD, second one is ABE, third one is ABC. So we need to make use of all those 3 right angled triangles. Now let us see this. So first of all, what we are going to do is we are going to consider BC is equal to some 3A. Consider BC as some 3A. Then automatically what I can say, BD is equal to DE is equal to CE is equal to EA. Because so this becomes A and A. Then total BC is 3A. That means BD is equal to DE is equal to C is equal to S, because all these 3 parts are equal, he said. Now moving on with each triangle. So first in triangle ABD. So in triangle ABD, by Pythagoras theorem. So by Pythagoras theorem what I can say, AD square is equal to AB square plus A square. AB square plus A square. So let this be equation number 1. Next in triangle ABE. Again by Pythagoras theorem what I can say, by Pythagoras theorem AE square is equal to, so AE square is equal to AB square plus, what about BE square? So BE is nothing but 2A. So BE is nothing but 2A whole square. So which gives me AE square is equal to AB square plus this becomes 4 times of A square. So let this be equation number 2. Next moving on to the third one, in triangle ABC. So this is the biggest triangle. So by Pythagoras theorem what I can say, AC square is equal to AB square plus this length is 3A whole square. Now from this I can write as AC square is equal to AB square plus 3 square is 9. So 9 times of A square. So let this be equation number 3. Now what do I need? So I need to prove 8 times of AE square is equal to 3 times of AC square plus 5 times of AD square. Right? So for that what I should do? Now first of all I need to substitute these values and by taking LHS and RHS. Okay, so first of all I am going to take RHS. So since RHS contains 2 terms, so directly taking the RHS. So what is RHS here? 3 times of AC square plus 5 times of AD square. Now this I can write as 3 times of AC square means already we know AB square plus 9 times of A square plus 5 times of AD square. I can write it as AB square plus A square. Now multiplying this, so this becomes 3 times of AB square plus 3 into 9, 27 A square plus 5 times of AB square plus 5 times of a square. Now this I can write as 3ab square plus 5ab square is 8 times of ab square plus 27a square plus 5a square is 32a square. Now from this I can take 8 as common. So if I take 8 as common, then I can write it as ab square plus 4 times of a square. Now already a means I can consider any of these three parts, right? Otherwise, so ab square plus 4a square. So where can you find this? ab square plus 4a square is nothing but equation number 2, which can be written as a square. Directly I can write it as 8 times of a square, which is nothing but my LHS. So likewise we can prove this question. So what he has given? So BC side is being trisected by the points D and E. So for that, for convenience, what we did? So we have considered BC as 3A, then BD became DE and CE all are equal and they are equal to some A. Now considering Pythagoras theorem for each right angle triangle, we got 3 equations. And what we need to prove? So we need to prove that 8 times of a square plus is equal to 3 times of ac square plus 5 times of ad square. So for that, what we have done? We have considered the RHS and we have proved LHS. Right. Next, moving on to one more question. So here what he has given, ABC is an isosceles triangle right angled at B. Similar triangles ACD and ABE are constructed on sides AC and AB. Find the ratio between areas of triangle ABE and ACD. Right. So he said that these two triangles are similar. So for that, first of all, what we are going to do? ABC is an isosceles triangle right angle at B. That means this side length and this side length both are equal. Okay. So for suppose, what I am going to do is, I am going to consider AB is equal to BC is equal to some A. If I consider AB is equal to BC is equal to A, then automatically if I want to find AC, that is nothing but the hypotenuse, what I should do? I need to apply Pythagoras theorem, right? So if you want to obtain the value of AC, I need to apply Pythagoras theorem. So by Pythagoras theorem, in triangle ABC, what I can say? AC square is equal to AB square plus BC square. From this, AC square is equal to, what is AB here? AB is A square plus this is A square. So from this, AC square is equal to 2 times of A square. From this, AC is equal to root 2 times of A. So we got the value of AC. So for suppose if this length is A, this length is also A, then this length is root 2 times of A. This length is also root 2 times of A, and this length is also root 2 times of A. The same way this is A and this is A. Now what is he asking? Find the ratio between areas of triangle ABE. If you observe this, since all sides are, he is showing that all sides are equal. So if all sides are equal, then it is nothing but an equilateral triangle. So already we know area of equilateral triangle, right? So directly what I can do? So area of triangle ABE by area of triangle ACD is equal to, so what is area of ABE? AB is nothing but an equilateral triangle, no? So from that, what I can say? Root 3 by 4 into A square. So A square means you can consider AB square by root 3 by 4 times of, so here I can consider AC whole square. Now this root 3 by 4 I can cancel it out. Already AB I know, so I have considered AB as A. So A square divided by AC is nothing but root 2 times of A whole square. Now from this I can write as A square by 2 times of A square. So A square I can cancel it out. I can write as 1 by 2. So from this directly the ratio. So area of triangle ABE is to area of triangle ACD is equal to 1 is to 2. So the ratio is 1 is to 2, right? So likewise you can find out the area, the ratio of area of those triangles Okay, so these all are nothing but the applicative part of my Pythagoras theorem. Right, so thank you for watching the video. Stay connected with the channel. So stay connected with the channel and share with your friends for further more videos. So please press on the bell icon for instant notifications. Right.